Okay, for today's lab, okay, we will discover about introduction to MIPS and yes. Can you hear my voice?
Sir.
Yes. Yeah. Yeah. Anything? Okay, class, can you hear my voice clearly?
Boleh sir, sir. Asia kata dia ada ni. Tapi mic dia.
Okay.
Sir.
Right. Then, yeah.
Saya Ifah Najwa ada.
Kejap Buka balik. Kejap. Okay, I've forgotten to ask you if any of you I didn't call your name, please let me know. Maybe your name is not in my attendance list. Just let me know. Okay, apa dia? Siapa tadi?
Ifah Najwa.
Ifah Najwa. Okay, Ifah tadi saya panggil tak perasan kot. Ifah. Ifah nombor berapa? Nombor berapa Ifah?
Atas kod.
Ifah, okay. Ifah ada
24.
Dengan Asia.
Asia ada?
Asia dia cek saya, dia kata mic dia problem.
Okay, very good. Tak apa. And then Farhana ada? Farhana, you all kenal Farhana? Kelas? Kenal ke Farhana?
Kenal.
Ada kan? Dia memang regular ada kan? Kita takut dia ada mic problem whatsoever, you boleh tolong bagi tahu saya lah. Okay? Right, so it is supposed to be no problem lah. Okay, tak ada masalah. Okay? Right, so without further ado, let's continue with our lab today. Okay. Okay, so starting from today, okay, or this week, I have told you that all the lecture topics from this week until the end will be covered in your final exam. Okay, right? And for today's lab session, okay, we will learn about the introduction about the organization of microprocessor, okay, as well as how to program assembly language. Okay, by this end of the section of practical, students should be able to understand the component of microprocessor system, okay, and the function of each component. Right, the first one. Okay. Okay, second one, able to understand the architecture of MIPS, right? Okay, so under microprocessor, we have several types of microprocessor. Okay, the first one is the one that we are going to discover is MIPS. Okay, processor. The third one is able to understand the concept of assembly language and develop an assembly language program. Okay, right. The fourth one is able to understand QT-SPIM environment. Okay, right. So the software that we use to simulate, okay, or how we talk with microprocessor or CPU. Okay, so whenever we want to talk to CPU, we need to provide an instruction, right? Okay, in the form of programs. Okay, right. So in that sense, we are able to communicate, or we are able to ask the CPU to perform our intended task. Okay, right. So basically, the one that we are going to use, okay, the software that we are going to use is what we call as QT-SPIM. Okay, I believe most of you have already installed. I have already taken note. Okay, your name for those that have installed. Okay, so I'm supposed we can do it together during our lab session. Okay, right. Finally, load and track execution of assembly code in QT-SPIM. Okay, sorry. Okay, QT-SPIM is actually a simulator, right? Like if you want to be a pilot, okay, whenever it is the first time for you to have an experience in driving a flight, okay, therefore you will be introduced to a flight simulator, right? Okay, right. Okay, so similar to our case here, in order to simulate or in order to experience how to communicate with CPU, okay, we will use one medium or one software we call as QtSpim, right? So QtSpim is actually a simulator in which the simulator will emulate, okay, or will give a example, okay, how can we communicate, or how can we give an instruction to CPU, okay, but the CPU that we are using is not MIPS processor, right, but it is just a simulation software, okay. So we can see what is the results after we have given some instruction to the CPU, okay. Okay, therefore the software that we need is QtSpim. Okay, hardware is the PC lah, right? So regardless of what type of CPU that you are using, whether you are using MIPS processor or you are using different types of processor, it doesn't matter, because you can always see how to communicate with MIPS processor by using a simulator. Okay, simulator is just showing what is actually happened whenever you are communicating with MIPS processor, but actually your PC is not really a MIPS processor, okay. It is just an simulator. Okay, so like the one that I have mentioned to you earlier, right? Okay, you need to remember, or you need to aware, okay, about the details component or architecture of processor, right? In which processor, okay, I believe I should show my online whiteboard lah, in which this one is more comprehensive, okay, right? Okay, can you see my Yulen, which is my online whiteboard class? Can you see? Boleh nampak kan?
Yes.
Okay,
Boleh.
right. So I really hope that my online whiteboard will benefits all of you, right? Okay, because I will provide most of the very important information, okay, in my online whiteboard, so that you can refer to the flow of each of the topics, okay. Okay, so like what we have discovered during our lab session, okay, you need to remember, or you need to aware about the details components of CPU, right? Okay, right. So CPU may consist of what? Okay, how many core component of subcomponent of CPU class? Anybody volunteer to ask the three main component of CPU? Okay, still easy question. Volunteer please. What are the three?
CPU.
Okay, balik semula. Nama dulu. Name?
Aida.
Your name? Aida. Okay. Okay, Aida. Tell me the three core component of CPU or processor.
Alu.
First one is ALU. Okay. What is ALU, Aida? ALU tu apa?
Arithmetic Logic Unit.
Arithmetic Logic Unit. Very good. Second one is
CPU. Register.
CPU or CU? CPU or CU? CU kan? Control
CU.
Unit. Control Unit Okay. The third one is
Register.
Register. Excellent. So very good, Aida. Okay. So you can find out the answer, okay, in my online whiteboard lah, right? Okay, so basically you can remember by giving any funny names lah, such as Chu, Alu, and Register. Okay, Chur. Okay, sorry, Char. Okay, Chu, Alu, and Register. Control unit, which will control the fetch operation. Okay, when should we get the data? Okay, from memory or from register. Okay, right? And then we need an ALU. Okay, arithmetic logic unit. Okay, so it is resemble its meaning from arithmetic, means that in the ALU it will perform arithmetic operation such as add, subtract, multiply, and so on. Okay, and the most important is the memory of the CPU, which is the registers. Okay, how many registers class in MIPS processor that we're going to learn now? How
32.
many? 32, right? Okay, in which we have 32 register. Okay, name me the register from register what until register what?
$S, $S0 until
$S0.
$S31.
31, excellent. Nama?
Syafiqah.
Syafika, excellent Syafika, right? Okay, so ini kita dan each of the register, the size is 32 bits. Okay, each of the register, the size is 32 bits. Okay, that's why you can come into conclusion that okay, the processor we call as 32-bit processor, right? Okay, so you have to remember, okay, the core component of CPU consists of two ALU and registers. So these are the components that going to be investigated in details lah during our lab session today and onwards, right? Okay, instead of that, okay, after processor, you need also to communicate with the RAM, right? Means that the RAM is external from the CPU and it is attached to the main board or motherboard. Okay, right? So afterward, you can able to investigate the content of a register as well as the content of memory, right? In which the register is the internal memory of CPU, okay? And the memory or the RAM is the external to the CPU, right? So afterward, you may see, okay, the data that being transferred from register and to memory, okay, right? Okay, so that is a little bit of introduction. Okay, what is data path is also called ALU that performs arithmetic operation such as add, subtract, and so on. Okay, then we have the control unit, okay, or CU, the component of processor that send a signal that determine the operation of data path, memory input and output. It will controls whether, okay, currently the process is either to fetch. Okay, please take note. This is very important key points. Okay, this is what we call as machine cycle. Okay, right? Okay, the machine cycles basically consist of four main steps. Okay, which is the first one is the fetch. Okay, this is just like you fetching your brother from school. Okay, means that you have to bring the car. Okay, you bring the car, okay, to fetch your brother from school. Okay, and then we have a decode. Okay, right? Okay, decodes means that trying to understand, okay, the meaning of that instruction. Okay, and then execute. Okay, right? Execute. Okay, right? Okay, so execute means that you will either read the register or you will execute the arithmetic operation. Finally, you will perform the store. Okay, okay, so basically the main operation is the main machine cycle we call as FDES: fetch, decode, execute, and store. Right? Okay, so that is the basic process we call as machine cycle. Okay. Okay, so please remember FDES. Okay, fetch, decode, execute, and store. Okay, so sorry. Okay, so the machine cycle will be done by the control unit lah. Okay, control unit. Okay, the subcomponent of CPU. Okay, and the other one we have the memory. Okay, what is the memory? Okay, memory is the storage area where programs are kept when a program is running and contains data needed by the running programs, right? Okay, so whenever you write any code, let's say you write this assembly language program in Notepad, okay, so you need to load this program into your QtSpim, right? Okay, so your program consists of multiple instructions, right? Okay, so these are the instruction. Okay, class, can you see my program, class? Can you see my program? Nampak ke?
Nampak?
Nampak, eh? Right, so this is the first what we call as assembly language program. It is looks like the appearance in general just like your C language lah. You must follow the correct syntax. Okay, so remember yesterday we have this tanda pagar, okay, hash symbol. Okay, can you still recall what is the function of the hash symbol, class? Hash symbol is for what? This one. Hashtag for what? For?
Comment.
Excellent. Nama bagus lah. Nama siapa?
Fazira.
Fazira. Okay, very good. Okay, so you can remember what you have done yesterday. Okay. Okay, what about $9? $9 is for what? Anybody want to answer this simple question? Before difficult question come across. What is $9 class? Jangan lupa dah. Cepat. Siapa tak jawab, kita will stay until this question. Okay. What is the meaning of $9? For what?
First register.
Register number 10 lah kan. Okay. Because we start the first register is register 0. Nama tadi? Nama? Aida. Okay. $sign is for register, right? Okay. So this is actually the register, or this one we call as one instruction, one assembly language instruction. And what about all the lines here? We call as what? They complete all the lines here. We call as what? What is this? What kind of program is this, class? Is it C language program or what? Quick. What program is this, class? Okay, search for the answer, or you may discuss. Okay, what type of program is this? Is this C language program?
No.
What program is this?
Assembly.
Language. Very good. Nama?
Hasana.
Ana. Okay, Asana nak bikin nama panjang sikit. Right, anyhow, very good, Asana. Okay, so this is example of assembly language program. Okay, right. Okay, so we do a revision first lah. Okay, so we have or here, ori, or with immediate value. Okay, anybody want to tell me? Okay, if we refer to this line, okay, ori $9, $0, 0x3. Okay, which one is the opcode? Which one is the opcode, class? Which one is the opcode? Kita nak revise balik what you have learned yesterday. If you are able to answer quick, very fast, we can finish our class very fast. Even if in half an hour pun boleh siap. Which one is the opcode? Aku tengah discuss tu. Okay, which one is the opcode, class? For statement line 6. Which one is the opcode? Okay, you can refer to yesterday's note. Okay, whenever your friends answer the question or you're trying to answer the question, please take note in your notepad or in your paper lah. Okay, right, refer to line 6. Okay, ori $9, $0, 0x3. Okay, which one is the opcode? Which one? Ori, nama? Nurin tahu, excellent Nurin. Okay, so everybody should be proud of Nurin. Okay, so the Nurin's answer is correct. Ori is the opcode. Okay, Nurin boleh, kalau Nurin tahulah kan, which one is operand, Nurin? Lagi senang lah, dah tahu opcode. Which one is operand?
$9
$9 lagi?
$9
$0 lagi? 3 lah. 3 lah. 3 ni is I is for immediate. Remember? Ori, I. Okay, ori bermaksud or with immediate value. Okay, excellent, Nurin. Very good student. Okay. Right, now tell me which one is the destination register for line 6? Which register is destination register? Siapa nak jawab? Siapa nak jawab? Quick. Which one is the destination register? Kan, we have learned yesterday, right? Source register and destination register, right? Betul, guys. Yesterday we have, on Tuesday kita dah belajar kan tentang source and destination register kan? Is it true, class? Is it true? Class, quick.
$9.
Okay, $9. is the destination register. Means that the result will be stored in register 9. Okay. Okay. So it is the where we store the data. Okay. Okay. So $9 is equivalent to $sign sorry $0, okay, plus with hexa value 3. Okay. So in other words, okay, so this is the description. Okay, so in exam they will ask you to describe the meaning of each of the instruction, right? So it is equivalent to, okay, the content of register 0 plus with 3 in hex, and the result will be stored in register 9. Everybody clear, class?
Yeah.
Okay, so this one we call as destination register, and this is the source register, right? Okay, it is not we are adding value of 0 with 3, but we have to refer to the content of register 0. Remember yesterday on Tuesday we have gone through, right? Okay, so you have to check in register 0 what is the value of the value in register 0 plus with the value of 3, immediate value of 3, and the result will be stored in register 9. Right? Okay, so this is my first program. Okay. Okay, so we have a memory to store area where programs are kept when the program is running and contains data needed by the running program. Okay, input devices that writes data to memory, output devices that read data from memory and convey results of the computation. Okay. Okay, microprocessor operation. Most microprocessor will repeat basic steps to execute one machine cycle. Okay. Okay, so please read through the machine cycle first. Okay. Can anybody please recall back what I have mentioned to you earlier? Give me the 4 machine cycles applicable to MIPS processor. Anybody want to answer my question? What are the 4 machine cycle?
Fetch,
Okay, fetch,
execute, and store.
fetch lagi? Tak dengar. Tak apa jelas.
Decode,
Decode,
execute,
execute.
store.
Okay, finally store lah. Okay, right. So, but the major operation, okay, is these 3 lah: fetch, decode, and execute. Okay, right. In some cases, there are some instruction that require store. Okay, so that is the reason why, okay, the store is not being stated here, but some of the cases requires the store operation or machine cycle. Okay, right, but you can remember it consists of fetch, decode, execute. Okay, and some cases we need to include the store. Okay, okay, hold on, I will a few seconds. Okay, read through first, then we will continue. Okay, right. Okay, most microprocessor will repeat the 3 basic steps to execute one machine cycle. Okay, so means that if you are referring to these groups of instruction, okay, okay, every instruction, okay, every one of these instruction, let me cut this one first so that you can see. Okay, okay, every one of these instruction will have one machine cycle. Okay, every one of these instruction, okay, consists of one complete machine cycle, which is fetch, decode, execute, and store. Okay, let me cut it again. Okay, right. Each instruction, okay, this one we call as each instruction. Okay, each instruction, okay, consists of one complete machine cycle. Okay, right. Okay, consists of fetch, decode, and execute. Right? Fetch, decode, and execute. Okay. Okay. Then what about the following instruction? How many machine cycles should we have for the second one? Also, one complete machine cycle. Okay. Okay. So for these two machine cycle, let's say our program only consists of two instructions. How many machine cycle altogether, class? How many?
Two.
Two, right? So one one instruction, okay, requires one complete machine cycle. Okay, everyone need to have fetch, decode, execute. So this is what we are going to do. This is what we're going to trace in our assembly language simulator later. Okay, so I hope everybody clear lah, right? Okay. Right. Okay, fetch use the program counter to supply instruction address, fetch the instruction from memory, update the PC. Okay. Secondly, secondly is decode. Decode means that your CPU will try to understand, like the one that you have done just now, right? Okay, when I ask you what is the meaning of ORI, okay, ORI $8, comma $0, and 2, okay, then you are able to explain that this is the meaning of this is we add the immediate value of 2 with content of register 0 and the result stored in register 8. Okay, so during the decode process, it is just to understand, okay, what need to be done. Okay, but it is not yet being executed. It is just your CPU trying to get the meaning of the instruction, right? Okay, then only during the execute process, then only the execution will be done. It will read the content of register, okay, execute the instruction, okay, okay, if necessary, write the result to memory. Can you see here? Write. Okay. Another word for write is store. Okay. So during execution process, it will execute the instruction. Okay, right. So after that, after they have done the execution of the instruction, okay, they will decide whether the result should be returned to memory or returned to any else. Okay, or it is just repeating the same process again, which is fetching the following instruction, right? Okay, so the first instruction, okay, whenever you run this instruction, okay, okay, it will try to understand the meaning of the instructions. Means that whenever you type this instruction, okay, and then you load into the Qt Spin simulator, okay, okay, actually, okay, your program is not yet in the processor. It is still in memory, right? So whatever you do in your PC, actually it is actually being saved in the RAM first. Okay, right? Okay, so if you see my online whiteboard that I have draft for you, okay, okay, you can see here that all the the program that you have keyed in just now, it is actually in the memory. Okay, it is actually in the memory. Okay, sorry, this one is the memory. Okay, so actually all the programs that you have written, okay, this program, I have to minimize the size. Okay, this one. Okay, okay, the program that you have keyed in just now, okay, okay, is actually in the, okay, this one a little bit smaller. Okay, the program, the assembly language that you have keyed in and you have uploaded, but you haven't run the program. Okay, it is actually in the memory or in the RAM. Okay, in the RAM. Okay, or it is, where is it? Okay, or it is in here. Okay, it is in here. Then after you execute, then only they will perform. Okay, okay, the machine cycle. Okay, the first step in machine cycle is to fetch. Okay, so the program in the RAM is actually will be fetched from memory. Okay, and it will be saved into instruction register in your CPU, right? Fetch means that it brings hand, okay? It takes the instruction and then it loads into the CPU in the register in the memory of the CPU. Okay, so that's why I have drawn you these images. Okay, it is just like when you perform the fetch, actually it is just like a hand. Okay, a hand that fetch the instruction from RAM. This is the RAM, the details for the RAM. Okay, fetch the instruction for the RAM, and they will copy the instruction into register in your CPU. Okay, so that is the first step in machine cycle we call as fetch. Okay, right, we return back to our notes. Okay. Okay, class. Okay, so far everybody clear about the machine cycle? Okay, so this diagram is actually will summarize the machine cycle. First thing adalah whenever you load this instruction or you type this instruction, okay, and you load into QT-Stream, actually it is not yet in the CPU, but it is in the RAM. Okay, so you need to refer to the machine cycle, which is started with fetch. Okay, you can bring a hand from the CPU. Okay, so it will fetch the program. Okay, it will fetch the program in the RAM. Okay, fetch and bring it into register. Okay, so that is the first step. Okay, so far everybody clear, class? The machine cycle, class?
Yes,
Yes.
Okay, so the program that you type is not yet in the CPU. It is in the RAM. Okay, in the RAM. Okay, so it will be stored in the RAM. Okay, right. So then they will fetch from the RAM. Fetch means that they will grab the instruction from the RAM and then they will copy into register. Okay, right. And then after they have copied into register. Okay, it is the task for control unit, okay, to try to understand what is the meaning of that instruction. Okay, right. After that, okay, the ALU will perform the decode, okay, what already being understood, okay, such as the one that we have done just now. The first instruction is to perform the OR immediate. Okay, means that, okay, this is not add, it is just ORI. We OR with the value of register 0, ORI. Okay, means that we OR the content of register 0 with value of 2. Okay, okay, right. So after that, after we have done, ALU have execute. Okay, ALU is the most intelligent part of CPU lah, because it will process, okay, the arithmetic operation. Okay, after ALU have performed the execute, okay, so it will depends to the following step whether the result need to be stored or not, or if it is not needed to be saved or be stored. Okay, they will fetch to the following instruction. Okay, so the instruction will execute in sequence, right? So means that after you have done the complete step for the first machine cycle, okay, so the following, after we have done the first instruction, they will move on to the second instruction. That's the reason why you can see the chart, the flow chart here. Okay, after they have done the execute, they will go back to the fetch. Okay, means that after they have completely performed the first instruction, okay, then they will go to the following instruction and they need to start again with the similar steps in machine cycle, starting with the fetch, okay, and then decode and execute. Okay, right. Okay, every instruction starts by using program counter. Okay, later on we will discover what is program counter to supply the instruction address and instruction memory. Okay, so whenever you key in the program, okay, right, okay, so the CPU, okay, will fetch a specific memory location. Okay, okay, so a specific memory location, it is just like the address of the school or address of the house. Okay, therefore the CPU need to know where to fetch the data. Okay, where, or in our case, okay, in our analogy, okay, you have to know where is the address of the school of your brother or sister, right? So this one we call as program counter. Okay, program counter. Okay, right. So after we'll see the program counter. Sorry. Okay, the after instruction is fetched. The register operands use the instruction are specified by the fields that instruction of that instruction. Okay, right after it is being fetched. Okay, the following steps is to perform the decoding. Okay, means that they will investigate, okay, which part of the instruction is opcode and operand. Okay, once the register operand has been fetched, the operation stated in the machine instruction is performed. Okay, so this is the opcode lah. Okay, right. So it will simplify the steps of machine cycle, fetch, and then decode, try to understand the meaning of instruction, and then executing the intended task of that instruction. Okay, right. Okay, so this is what we have discovered on Tuesday. Okay, MIPS microprocessor with interlocked pipeline stages is a reduced instruction set computer, right? Okay, the first commercial MIPS processor is R2000, announced in 1985. Yes, 32 bits general purpose register. Okay, but no condition code register, right? Okay, as you can see here, this will describe in general about MIPS processor. Okay, so you can see here the memory or the RAM. Okay, again, you can see here the internal part of CPU consists of register, ALU, and CU lah. Okay, so how many register altogether? 32. From register 0 until register 31. And then the other architecture of MIPS R2000, they have their coprocessor. Okay. Okay, the figure shows MIPS processor. Okay. Okay, then after we will be using the SPIM. Okay, SPIM is the reverse for MIPS. Okay, to simulate the coprocessor or to simulate the process in microprocessor. Okay, and then we go in general about memory allocation. Okay, right. Okay, so based on figure 7.4, what is 7.4? Okay, this one. Okay, right. Okay, so this one we call as memory layout or memory mappings. Okay, right. Based on 7.4, system based on MIPS processor, divide memory into 3 parts. We have the text segment, data segment, and stack segment. This is just in general. Okay, right. Okay, so stack segment is rarely being used. Okay, and then we have the data segment, and we have the reserve area. Okay, so this is actually the memory area that you can use lah. Okay, right, in general. Okay, right. Okay, and then this is regarding the data alignment. Okay, so basically one memory location, the size is 8 bits. Okay, let's say if I can try to edit here. Okay, so every one memory location, hold on, okay, consists of 8 bits. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so one memory location is equivalent to 8 bits. Okay, okay, let's say okay the memory location, okay, is 7FFFFE. Okay, so the following one will be 8 0 0 0 0. How many is it? 0 0. Okay, okay, you have to count it. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Okay, right. Okay, so if you can see here, okay, Okay, the stack segment memory location is 7FFFF. Okay, right. What if you add with 1? 7FFFFF. If you add with 1, okay, what is the result, class? Anybody can answer this. 7FFFFF ni. If you plus with 1, what is the answer, class? Quick, very simple question. Just a simple hexadecimal addition. What is the answer, class? Cepat, kita nak balik awal ni. What is the answer? You get my question, class? Do you get my question? Class?
You add Y.
Add with 1, right? 7FFFF, add with 1. Okay, very good. What is the answer?
800.
The answer 0 1
0
8 0 0 0
0 0 0.
0
Ada 1 ke?
1.
Ada 1 ke?
No.
0.
Oh,
Eight,
all 0, right? Am I right? All 0?
Yeah.
Okay, so this is the answer, right? Betul?
Yeah.
Betul?
Yes.
The answer is already here. Okay, this is what I'm trying to tell you lah. Okay, so this is what we call as memory organization. Okay, right? Okay, and the one that you see in the box is what we call as the data. Okay, right? Okay, the one that you see at the left, this one we call as memory address. Okay, or memory location lah. Memory address or memory location. Right. Okay, memory address. Okay, the one that you see in the box is what we call as the data. Okay, or we call as the content of memory. Okay, so you can label this one. Can you see here, class? Okay, so for memory location 8000, okay, the data in the memory location 8000 is 01, 01, 01, 01. How many bits, class? How many bits for this one? Tell me, how many bits? For memory location 8000, how many bits? Quick, very simple question.
8 bit.
8 bits, you just count, right? Okay, just count the bits. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we can conclude that, okay, this is how to express how to rate this memory location. Okay, so for memory address 800000, okay, the data in the memory address 8000 is 01, 01, 01, 01. Okay, so you can store any value as long it is 8 bits. Okay, are you everybody clear, class? Clear?
Yeah.
Okay, right. So you have understood about memory organization. Okay, right. So the memory organization is just like your hostel. Let's study also on that, right? Because you have several floors, right? You have several floor for your hostel, right? Beberapa tingkat kan? Tingkat ground floor, first floor, second floor. Okay, so you can simulate. You can relate with your hostel. Okay, so the memory organization is just like that. Okay, we have several floor, which is the memory address, and we have the data inside that, or who is the penghuni lah, or who is the student inside the room or in the floor. Okay, are you clear, class? Everybody clear? Jelas?
Sir,
Yes.
Yes.
what the answer that you said, if +1 this memory +1, what is the answer, or the value is never not change, or what is the answer for +1?
Okay. Okay. My question just now is, okay, the top floor is 7FFF. Okay, right. So the next memory location we +1, right? Okay, just like your hostel, right? The lowest floor is the ground floor, right? Or floor 1, right? Okay, what is after floor 1? Selepas tingkat 1, tingkat berapa?
Second floor.
Second floor, right? So same goes to this one. You can remember that way. Okay, but it is just like apartment yang the other way around lah, ataupun yang terbalik. Okay, right? Okay, the bottom one is 7FFFF. Okay, the following floor is 80000. Can you get it? Okay,
Oh, so the plus one is the
memory
8000.
location. It's the memory location.
Okay, okay. I
But
get it, I get it.
the content is not adding anything. It is depends on the value that you input. It can be any value. Get it? Nampak? Jelas?
Yeah, I get it, I get
Okay.
it. Thank you.
Okay, so we try for the next one. What is the following memory location after 8000000? Okay, cuba jawab. Tadi siapa? Nak bagi bonus mark yang tanya tadi? Nak bagi bonus.
Honey.
Hani, okay, Hani. The following one. What is the next memory location? Salah tak apa.
9000.
Okay, cuba tambah dengan satu. Okay, 800000 plus with 1 at MSB. 9 ke?
MSB.
Bila kita tambah satu, macam kita tambah dekat tools complement, right? Like we do the tools complement.
We plus at the right side.
Sorry, LSB. Sorry, my mistake. LSB, you have to add with LSB. Okay, so what is the following memory location after 800000?
8000. Lastly one.
Okay, excellent. You know, right?
Okay.
Dah faham?
Yeah, I get it.
Okay.
I see.
So, okay, what about the data inside that? How many bits? Berapa bits semua?
8 bits.
8 bits. Must always be 8 bits. Contohnya 1111 or 0000. So no need to add anything. Okay, very good. Well done, Hani. Okay, the rest. Jawab je lah siapa-siapa. What is the following memory location after 8001? 8? 81 ke? 8, 0, 000, 0. Lepas tu? 2. Okay. Okay, let's say we have done until dot. Let's say we have done until 8 00009. Okay, then kita ada 02, 03, 04 until 09. Okay, I want to ask you, what is the following memory location after 80009? 8 0000 10 ke? 10 or what? A. Excellent. Why A? Because the memory address we assume as a hexadecimal numbers. Everybody clear?
Yes.
Okay, so I hope by explaining this way.
Binary system?
Come again?
Binary system. And right.
Binary inside at the right hand side. This is the data. You can put any value. Get it?
Okay.
Faisal?
Yeah.
You can be any value. It is just like your apartment. This is the floor of the apartment, and this is the people inside that apartment. Can be any numbers. Depends on the instruction.
Okay.
Get it, Faisal?
Yeah, I understand.
Okay, right? Okay, so I just want to explain to you the analogy or how to understand about memory organization. So this one we call as memory layout, or sometimes we call as memory organization. Okay, or we call as memory organization. Okay, so I hope everybody is clear. Okay, right. So we have 8 bit, we have word. Okay, right. Okay, so like we have mentioned, just we have discovered on Tuesday, 8 bits. We have this 8 bits. Okay, consists of 2 hex digit, right? And then we have the double word. Okay, right. So this one we have done during our lecture on Tuesday. Okay, 2 bytes is equivalent to half word. Okay, 4 bytes is equivalent to 1 word. Okay, so 8 bytes is equivalent to 1 double word, right? Okay, so we discover about registers because we are already 3:30. Okay, the mix contains 32 general purpose register. They are numbered 0 to 31. Okay, register 0 always contains value of 0. Register 1, 80. Key and so on. So this is the reserve register, right? Okay, register A0, $sign A0 until $sign A3. Okay, or $4 until 7 are used to pass the first 4 arguments routines. Okay, this one you don't don't think it too hard. Okay, just read it through. Okay, so because we will be using during the later session. Okay, okay. Okay, then we have the global pointer. Okay, we have the stack pointer and so on. Okay, right, and we have the RA return address. Okay, so this is the function. Okay, this one you can memorize lah. Okay, right. So we have the register 0. Register 1 is for a temporary assembler temporary. Okay, register 2 and until register 3 also we can call as register V0 until register V1 expression evaluation. Then we have register 4, register 7 and so on. Okay, right. So this is the description for the each of the register. Okay, right, and this is the trap register. Okay, don't worry much about it. Okay, right. Okay, I'm not thinking about going through all these details. Okay, right. Okay, and the system calls. Okay, Spin Simulator for MIPS architecture provide exception handler that simulates a tiny operating system that can do input from keyboard and output to the monitor. Okay, right. Assembly program requests a service by loading the system call, syscall. Okay, so later on we will see one of the instructions in your program is a syscall. Okay, so sometimes you have the instruction of li, okay, $ v0 code, load v0 with the system call code. Okay, so this one don't worry much, it is just like C++. Okay, normally the C++ will start with main, right? Is it true, class? Your programming technique, okay, you must start with main, am I right, class?
Yes.
Okay, and you have to end with what? Semicolon, right? Sorry, you have to end with close curly bracket. Am I right? Is it true, class? Right.
Yes.
So this is something like the C++. You have to start with this one. Okay, and you may end with syscall. Okay, so you can put all your parameters or your programs in between these two lines of codes. Okay, right. Okay, so this is in great detail. Whenever you have mastered, okay, you can further explore about this one. Okay, so we can have here print integer, okay, to print integer, print float to print the float, print double to print double, and so on. Okay, okay, read float is to read float or read numbers. Okay, exit to end, it is just like close curly bracket for your C++. Okay, right. Okay, so this is the lines of instruction that you need to insert so that your spin does not crash. Okay, so you can use li $v010. So don't worry much about the meaning of this one. Okay, so you just digest it. Load v0 with code 10, which is exit, and syscall is to perform the execution so that it doesn't crash. Okay, right. The MIPS assembly program format. Okay, right. Okay, so this is what normally appears lah. So if you can see here, okay, let me show side by side. Okay, okay, you can see here that, okay, let's say, okay, let's say for the instruction number 5 or the line 5 for your assembly language program. Okay, so you can see ori $8 $0, okay, comma 0x2, and you have the hashtag here, right? Okay, so this is what a popular question in exam. They ask you to label the single instruction, right? Okay, so the leftmost, okay, the leftmost, this one, I suppose you can put to the right a bit. Okay. Right. Okay, so the leftmost, okay, the leftmost part, this area we call as the label part. We may put the label. Okay, the label is just a looping. Okay, okay, means that we can loop the program. Okay, let's say we want to repeat the process, okay, over and over again. okay, we may put a label here. Okay, so whenever they comes into that instruction, they will point that instruction to the looping label. Okay, right? Okay, and you can see the second one is the opcode, right? Let me close this one. Okay. Right. You see the column 2, which is the opcode. Okay. Okay, the column 1 we have discovered, right? The left part. Okay, let's say main. Okay. So the main is the label. Okay. So the main is the label, right? Okay. And then for column 2 is the opcode. Okay, for line 6. Okay, tell me which one is opcode class? Which one is opcode? Tadi kita dah jawab kan? Just repeat again je. Okay, for line 5, which one is the opcode class?
Ori.
Ori, very good. Okay, what about operand? Which one is the operand?
$sign A, $0, 2.
Tu, nama siapa?
Aida.
Aida, excellent Aida. So understood lah. Aida, excellent right? So we can have label, opcode and operand. So this is a popular question in exam. And finally the comment lah. Okay, the one after the hash will be the comments. Okay, everybody clear class? Jelas? Clear?
Clear.
sir.
Okay, very good.
InsyaAllah.
Boleh jawab Boleh score insyaAllah. Right.
InsyaAllah boleh.
And then we have the label such as the main. Okay. Okay, label is used to mark the specific point in the program code. Okay. In case when instruction branch or jump. So this is what I have told you lah. Okay. So you can see here J, right? J is for jump. Jump is that lompat. Okay. So we will run instruction in sequence. Okay. Start with the first instruction. Okay, we perform the fetch, decode, execute. Okay, lepas tu we run the second instruction, fetch, decode, execute, and then we run the third instruction, fetch, decode, execute, and finally we run the fourth instruction, fetch, decode, execute, and then we run the following instruction. Okay, so if you can see here, we see the instruction jump, J for jump. So means that whenever they see the jump, okay, they will jump to the label. Okay, so which label that we want to jump is the main, right? Okay, so main is is available in which line class? Main. Which line? Line number? Main. For label main. Located in line number 1. Excellent. So means that, okay, we can use the label, okay, whenever we have a branch or jump. Means that if we arrive here, they will repeat back the process of running the first instruction. Sampai sini, okay, they will jump, repeat again the instruction. Are you clear, class? Jelas? Okay. Okay, opcode is the field that denote the basic operation. Okay, so by looking at the opcode, we know that the processor know that what need to be done. Okay, then what is the format of that instruction? Okay, okay, mnemonics means that the shorthand lah, singkatan, is used rather than hexadecimal. Mnemonic singkatan such as, okay, ADI, right? ADI is the shorthand or short form for additional with immediate value. Add with immediate value. So it is what we call as mnemonics or shorthand or shortcut. Okay. Okay. Example of opcode, okay, or mnemonics such as ADU. Okay. Add with immediate value. Okay. And then we have add. We have for multiply, right? Okay. The second column is the operand. Operand contains register. Okay. Such as this one, we have register 0, and 0. Okay. Right. And finally, the command is anything that follows it on the line. Okay. So whenever the compiler see the hash, okay, sorry, the assembler saw the hash, okay, the assembler wouldn't process anything. Means that it is not a syntax, no need to be done. It is the assembler will ignore. Okay, it is just like comment in C++. You can use double slash, right? Okay, so whatever in the after the double slash, you can write anything, okay, without concerning about the syntax. Okay. Okay, so everybody clear so far about the format of instruction? Everybody clear, class?
Clear.
Okay, so this is popular question. I tell you again. Okay, popular question in the exam. Okay, right? Okay, so this is the instruction that we will use afterward. Okay, so this one have been specified for you. Okay, so the first, the leftmost part is the label. So I think I can show you side by side. Okay. So you can see here we have the data, we have the text, okay, and then we have the main, indicates the start of the code. Okay, right. Okay. Let's say you have Ori. Okay, you have Ori $8. Okay, 0x2, right? Okay, so this is the first instruction. Okay, and then you can insert the following instruction. Okay, so the distribution of the format is the label. Okay, the coding part, the instruction part, and the rightmost is the comment. Okay, right. The data representation, this one you can read by yourself later lah. Okay, right. Okay, so this is the equivalent conversion. Okay, from decimal, hex, and so on. Okay, okay, number representation. Okay, like this Ori. Okay. Okay, Ori $5, $0, $15. Okay, load number 16 into register 5. Okay. So Ori is a short form for all with immediate value. Okay. Okay, so means that we know that the content of register 0 is always 0, right? So if you all with 16, okay, so the result stored in register 5, what is the result in register 5 class? If the value of 0, you all with 16, what is the value? Okay, the register 0, 16, right? Because any value that you all with 1, the answer will be 1. So exactly whatever you all will be that result. Okay, so 16 all with 0, so the result will be 16. So the 16 will be stored in register 5. Okay, right. Okay, now we will discover about the simulator that we are going to use, which is the QtSpim. Okay, let me show the QtSpim. Then you can run your QtSpim by clicking the QtSpim. So we will see together. We'll discover together QtSpim. Okay, let take half a minute letting the QtSpim to execute. Right, this one you can minimize. Okay, this one you can put to the left. Okay, minimize the size. Sorry. Okay, it's a matter. Okay, right. Okay, what is QtSpim? Okay, it is let me put side by side. QtSpim, I close one first. So many will conserve a lot of resources. Okay, QtSpim ni because the size of the window is very big, so I didn't resize lah. You can use a normal actual size. Okay, so the QtSpim is what we call as emulator. The fundamentals of emulation. Okay, so Apple computer can run Windows files application instead for Intel processor. Okay, so in other words, okay, by using emulator, okay, means that it is just like your flight simulator. Okay, flight simulator is not, it is not you that drive the actual flight or actual airplane. Okay, but it is just like installing a flight simulator in your PC. And you can also install the flight simulator in your Linux laptop, or you may also install the flight simulator software in your Android phone. Can you see that? Okay, so regardless of the processor, okay, you can still emulate. Okay, if you are not using emulator, okay, you are not able to understand how MIPS processor works because your processor is not MIPS processor, right? So by using emulation, okay, you can work as it is a simulation. So it is just like working at a real processor. Okay, right? Okay, so the one that I mentioned to you earlier, right? Okay, so the program that you type here, hilang tadi. Okay, this one. Okay, this program that you have typed here. Okay, this one we call as the assembly source code, right? Okay, so after that, okay, you need to assemble. Okay, okay, you need to assemble. Okay, what you need to do is you need to load to this QtSpim. right? Okay, and then you will be given, after you have passed through assembler, the assembler will translate into machine language or object module, right? And the good thing about this simulator, you can see every instruction, one instruction after another. Okay, that is the thing. Okay, so QtSpim is a self-contained simulator. Me make it bigger. QtSpim is self-contained MIPS simulator that runs MIP 32 programs. Okay, right? Okay, so we have a 32 general purpose register, right? Okay, QtSpim is free, can be searched easily from the SourceForge. Okay, so this is the screen of your QtSpim, just like mine. Okay, okay, mine is a little bit bigger. Okay, this one not able to resize, but I can put it to the right. Okay, okay. So you can see at the left, okay, these are the registers. Okay, you can have R0, R1, until finally you have R31. Okay, okay, all together, how many registers that we have here, class? How many registers?
32.
32 from R0 until R31. Okay, very good. Lepas tu kita ada PC. PC is the program counter. Okay, so this is the interesting that we want to discover afterward lah. So program counter is the address of the school. Okay, address of the memory location where we want to fetch the instruction. Okay, and the one that you can see at the right. Okay, so this is the register. Okay, in which this is your CPU. Okay, then instead of the CPU, what else? The memory that we have in our PC system instead of register. Give an example of memory that we have.
RAM.
Just now we have RAM, right? Okay, so the one that you can see at the right is the RAM. Okay, okay, the one that you can see on the right is the RAM. Okay, so this is the memory location 40000. Okay, in which okay, you can see in between with 4000, and then you can see the next memory location is 4004. Okay, by right, it's supposed to be what memory location, class? 400 after 4000. 400 1. Okay, so this one resembles, actually this is consists of 4 memory location. Okay, okay, 1 memory location, 2 memory location, 3 memory location, and 4 memory location. Okay, so it is just an example, it's not actual. Okay, so it depends on whether it is low endian or high endian. Okay, or a big endian or a small endian. Okay, right? Okay, so 8000 could be the content of 4000 is 8F. Okay, okay, for 4001 could be, okay, cannot highlight. Okay, could be A4. So actually 8F is in the form of hexadecimal. Like I have mentioned to you earlier, one memory location equivalent to 8 bits, right? So basically this is the memory location, okay, where your instruction being fetched. Okay, so memory location where your instruction being stored lah. Okay, right? Okay, so let make it cut it short because we are late already. Okay, so now we are going to write our first program. Okay, class, are you ready to start with our first program? Everybody ready? Can we start now? Boleh ke?
Yes.
Okay, have you key in the program? Okay, so in order to key in the program, you can use any editing software such as Notepad. Okay, for my case, I'm using Notepad++, this one. Okay, I'm using Notepad++. What is that? Okay, done. Okay, right. Okay, so you can type the program. Okay, let me put side by side. Okay, this is the program. Okay, okay, so you may type using any notepad. Okay, so anybody have finished keying the program? Quick, done. Typing in notepad. Anybody finish? Class? Siapa dah siap? Cepat kita nak habis cepat ni. Done? Or anybody stuck? Can ask quick so that we didn't drag the time. Dah siap lah? Dah siap key in the program? Or still key in the program? Okay, anybody have finished? Please let me know. Or anybody have question? Please let me know as well, so that we are not waiting too long. So you open the notepad or notepad plus plus and key in each of the program. You type the program to add 2 plus 3. Okay, and then you key in the code. Okay, right. Okay, anybody finish or anybody start here? Okay, Liu, have you finished key in the program, Liu?
Yes.
Done. Finish. Finish, Liu.
Yeah.
So I'm waiting for your response actually from any of you. Okay, Pang, finish, Pang. Pang. Boniface. Boniface, are you with me?
Not yet, sir. Not yet.
Not yet. Okay, until which line now, Boniface? Which line? Ori, Adu, Li. Or you face any difficulty, just tell me. Everything's okay, Boniface?
Okay.
Okay, right. Okay, so it's okay. I'm glad to hear that. Right. Okay, so you have told me that you have finished. Okay, so let's continue lah without further ado. Okay. Okay, let's say you have done this one. Okay, you save as. Okay, save as. Okay, you save as this number. Save as this file name. Okay, add up.asm. Okay, so you make sure you type as add up.asm. Make sure you put as .asm and then click save. Okay, everybody clear? Clear?
Yes, sir.
Okay, the response so that we can continue as quick as possible. Okay, after you have done, okay, you have a look to the following step. Okay, right. What you need to do is you need to load the program. Okay, and then you on the QtSpim here, right? Okay, and then you click load file. Okay, click the load file. This one, load the QtSpim. Okay, click to load file. Okay, you click to load file. Okay, and then click to this file. Okay, now you are in this file again. So the best thing is whenever you want to start, you click to the simulator, you clear the register and reinitialize simulator. Okay, right? Okay, and then you can you have upload the instruction, right? Okay, or you can load it again. Okay, click here. I repeat again. Okay, load the program that you have keyed in just now. Okay, right? Okay, and then this is the program that you have keyed in earlier. Okay, try to look into this program. Okay, can you feel any similarity? Can you see any similarity? One. Okay, so I put to the left hand side. Okay. Okay, can you spot any similarity here? Your program and the data or the instruction in RAM. Okay, so the one that you see here at the right hand side is actually the instruction in RAM. Okay, the one that you see at the right hand side, the one that I point. Okay, class, can you see the area that I have pointed now, class? Can you see?
Yes.
Okay, so this is the memory. Okay, means that every time you load the program into the QT stream, okay, firstly, okay, the data is not in the register yet. It is in the RAM. Okay, so you can see here we have ORI $8 $002. So you can find it is here. Okay, and then we have $903. Okay, right, and then we have ADU. Okay, right. So can you see here, class? So after you have upload the the program, you can check your program whether it is in the RAM or not. Okay, can you see, class? The one that I have highlighted now?
Yes.
Okay,
Yes.
right. So means that you are successfully uploading your program lah. Okay, so what you see here, okay, we go one instruction after another. Okay, so it is actually okay. Whenever you load the assembly language program, it will load into RAM. Okay, if you can see here, okay, in memory location, okay, RAM is referring to memory location. Okay, 004, okay, 004, 0024. Okay, if you can see here, okay. Okay, the memory location starts by 24. Okay, consists of ORI $8 $02. So actually, okay, this is the assembly language. Okay, and the one that you see here is the machine language. Right, this is the language of the machine. That is the reason why, if you can see here, okay, right, you can see here 3 4. Okay, you can see here for this line, okay, 3 4. Okay, 3 4 you can see here is for ORI. This one also 3 4 is for ORI, and this one is ORI. Okay, this one is also 3 4. Okay, because you know that, okay, machine only understand binary and hexadecimal number. Okay, but you understand high level language lah, or higher level language, right? Okay, so basically this is the data in memory location. Okay, so this is one memory location. Okay, 34 is one memory location. 09 is another data in another memory location, and 00 is data in another memory location, and 03 is data in another memory location. And you can we can say that this is the machine language. Okay, 34090003. Okay, in which this is the one that being converted by the assembler into machine language, and this is the assembly language instruction. Okay. Okay, everybody clear? Clear, class?
Yes.
Okay, right. So now we go to the following step. So we have uploaded our first program. Okay. Okay, so the first step is we want to investigate, okay, what is actually happening in the CPU, as if we cut the CPU and we see what is happening inside the CPU. Have you ever see whenever we cut the engine, we can see the piston moving? Pernah tengok tak? Have you seen it, class?
No.
You cut the engine of the car, and you can see the piston moving, right? The
Yes.
shaft moving. Am I right? Betul?
Yes.
It is just something like that. It is just like we cut through the CPU and we want to see what is happening inside the CPU. Okay, right. So in order for that, we have to execute the instruction by using this one we call as single step. Okay, single step. So the following step is to like in C++, you compile, right? After you compile, you will run the program, right? Okay. So for assembly language, okay, we can use or we can run the program using this single steps, or we can run using this one. But the bad thing is if you run using this one, okay, they will run everything until the end, and you cannot see what happens if we want to see the running of the processor instruction by instruction. Therefore, if you want to see what is happening if you run instruction by instruction, you click here, the single step. Okay, are you clear class so far? Is it clear until now?
Yes.
Okay, right. Okay, so you can either use this one single step, or the easier one is you click here. Okay, if you are not able to see this button, you can click to simulator and you click to single step. Okay, the same image. So for my case, I click here, or when I hover the mouse here, they will show it is a single step. Okay, can we start now, class? Can we start? Can we start now?
Yes.
Okay, so normally, okay, the program will start in sequence, starting from the first instruction until the final instruction. So, okay, so which one is our first instruction, class? Which one is our first instruction? Ori, $8 kan? Okay, so we click here, single step. Okay, so sorry. I want you to investigate the register here. When you perform the single step, I want you to investigate the register here, starting with the program counter. Okay, currently what is the value for program counter, class?
0.
0. So program counter is actually the fetching mechanism. Okay, so like I've told you earlier, in order to fetch your brother or sister, you need to know the address of the school, right? Okay, so in order for us to know what is the instruction to be fetched, okay, so the one that save the address is what we call as program counter. So afterward, you can observe, okay, the value in program counter register. PC is also a register, okay, will change. Means that the program counter will point to the memory location where the instruction is located. Okay, so we start with the first single step. Click the first single step. Okay, can you see here? The program counter now changed from 0 until what, class? Is it changed, class, the program counter?
Yes.
Yes.
Okay, so the program counter changed into what memory location?
40004.
40004. So it is actually fetching, okay, or referring to RAM memory location 4004. Can you see, class? Can you see?
Yes.
Right. Fetch means that they identify the memory location, right? Okay, so let's perform the following single step. But I want you to observe, okay, we are not concerning about the earlier instruction because this is a machine routine. You are not including all the instruction. Am I right? You are not typing the instruction, right? It is suddenly appear in this QT Am I right, class?
Yes.
Yes.
Yes. Okay, so you just concern with the instruction that you have typed in. So this one is automatically generated. Okay, so you perform the following single steps. Okay, so now currently it is pointed to memory location 40004. So now you click to the single step. Okay, so if you click to this instruction, what do you think the following value for program counter? Just guess or just tembak. Okay, what do you think the following content or the address pointed by program counter?
400008.
Excellent. Okay, so actually the program counter will point to the memory location of next instruction. So this is the first instruction. So if you execute one more step, it will point to the instruction for the next the memory location of the next instruction. So let's try to single step again. See, it changed, right? Am I right? Can you see?
Yes.
Yes.
Okay, so it is actually the function of program counter. It will point, okay, to the memory location of next instruction. Then you perform the single step again. Okay, so that one we didn't concern. Okay, we just play. Okay, okay, just single step again. See, you can see it's pointing here, right? Okay, Right, so we are not concerning yet. Okay, we go on to the following one. Okay, following instruction. Oh, so I think I better stop because it is already clear register. Okay, upload again. Okay, I have jumped one instruction. So we single step, start again. Okay, start again, start again. Okay, right. Okay, now starting the starting point. Okay, is it the instruction that we have typed just now, class? Is it reaching the instruction that we have typed, class? Dah sampai ke?
Sampai.
Yeah.
Sampai, right? So we are looking for Ori. You can refer to the left hand side. Ori $8. Okay, I think better this one. I put it same indentation so that can easily see. This. Okay. Okay, so we are looking to this instruction, okay, which is Ori $8 $0 2. Okay, so this is the instruction at memory location 40024. Okay, the PC should point to what memory location, class? If you point to this instruction, the PC should point to which memory location? Tell me. Yang tengok jawapan, you can just refer to the memory organization. So currently, PC is pointing to what memory location? Everybody think about it and then check with your friend answer. What do you think? PC, program counter is point to which memory location? Tadi you dah jawab kan? Okay, quick. Volunteer please. Before I call anybody to answer. Still simple question. Currently, PC is pointing to which memory location? Okay, class, do you get my question?
400.
Okay,
24.
4000. Lagi?
24.
Excellent. Nama-nama?
Waveform.
Wavefeng, excellent Wavefeng. So you can see here, is it similar to the PC here? Sama tak?
Sama.
Similar, right? Okay, so whenever you run single step, okay, it will fetch, okay, the instruction, the memory location which store that instruction, which is 4002 and 4024 could be 34, 34, okay, and 25 could be 08, it depends, okay, and so on, right? Okay, so okay, currently, okay, we want to investigate the register. Okay, register 0. What is the value of register 0, class? Now we want to perform single step, right? Okay, what is the value? What is the content in register 0, class? Now you investigate the register. What is the content? Register 0?
0.
0, very good. What is the content of register 8? Search for register 8. What is
Also
the 0, right? Okay, so now we are executing this instruction. Okay, okay, so if I click single step, what will happen to program counter? Tell me. This is exam question. Okay, they will ask you to explain. Okay, if I perform next single step, what will happen to program counter? Program counter will point to?
400028.
Okay, the program counter will point to memory location 40028. Very good. Nama siapa nama?
Aida.
Aida. Okay, sekarang kita investigate. Register 0 is 0, register 8 is 0. So whenever the program counter fetch, okay, means that the instruction is not yet being executed. Remember the machine cycle? Okay, tell me again. A good idea. Okay, what are the machine cycles? What are the steps in machine cycle?
Fetch.
Fetch. Lagi?
Decode.
Decode. Lagi?
Execute.
Execute, right? Then some case store, right? Okay, so this is the still a fetching process. So whenever the program counter fetch the memory, the instruction, it is not yet being decoded. Okay, so whenever you click the single step, then only it will be decoded and execute. Okay, if we execute this instruction, what do you think will happen? What register will change? What register will change?
Register 9. Register 8.
Register 8. Register 9 dah change ke tak?
Tak.
Register 8 tu dah betul. Nama-nama nak bagi bonus mark. Nama siapa?
Aida.
Aida, okay. Aida, register 8 tu dah, you kata tadi berubah kan? Register 9 berubah tak?
Tak.
Is it change? No, right? Because it is not yet being executed. Right? Okay.
Yes.
So register 8 will change to what value if we execute this instruction? Register 8 will have what value? What? 2. 2, right? Okay. So the content of register 8 after we execute this instruction will be 2. Okay. Everybody clear? Class?
Okay.
Okay. Let's try. Okay. Click the single step. Okay. Can you see? R8? Can you see, class?
Yes.
So this is what we call as simulator. Okay. Simulator, it is like you cut through the CPU and see what happening inside the CPU. Okay, you can see the brain, how the way brain store data, what is the memory in the brain, right? It is just like I have tell you earlier, analogy is just like you cut through a machine, like Formula 1, right? Okay, Formula 1, you if your car, you cannot see what is moving inside your engine of your car. Okay, but some cases, okay, they will have a simulation showing the shaft moving, the piston moving of the engine, right? Okay, very good. Okay, so now the memory is pointing to memory location 40028. Okay, for the time being, is it value of register 9, is it changed already or not yet?
Not
Not
yet.
yet.
Not yet. Okay, so how to see how this instruction works? What we need to do? Click to where? How if we want to see the results of this instruction? We need to click to where? I have told you just now. Click to single
Step.
step. Okay, click to single step. Okay, what happen if we click single step? What will change?
Register 9.
The content. Okay, very good. Okay, actually the correct answer is the content of register 9. Okay, so before we execute the single step, what is the earlier content of register 9, class?
0.
0. Okay, what happens if we execute this instruction?
Register 9 become 3.
Okay, the content, the correct answer. Okay, anyway, it's a good answer. Okay, cuba lagi sekali. Okay, cuba supaya you dapat jawapan yang betul.
The content will become 3.
The content of register 9 is
Register 9 is 3.
of 3. Okay, so single step. Is it 3? Class? Correct?
Yes.
Okay, now you want to perform this following instruction, right? Adu means that we add the content of register. Okay, what register we want to add now, class? Adu $10, comma $8, $9. Okay, so what is the meaning of the instruction, class? Okay, what is the meaning of this instruction? I put question mark. What is the meaning of this instruction? Okay, adu is the add. It is just like add register. Remember the format is opcode and operand. Okay. Okay. For this instruction, okay, which part is the source register? Which part is the destination register? Okay, this instruction. Okay, which one is the destination register, class? Tell me. Quick. Habis ni kita boleh balik. Register 10 is the destination. Means that the final result will be stored in register 10. Okay, which one is the source register?
Register 8.
8 je.
9.
8 and 9. Okay, so what is the meaning of this instruction? This is popular exam question. What is the meaning of this instruction, class? What?
Add register 8 and register 9.
Okay, and then the result stored in?
And the result will be stored in register 10.
Excellent. Nama. Cemerlang. Nama?
Aida.
Aida lagi. Okay, so it is equivalent to the content of register 8. Okay, plus with the content of register 9. Okay, and the result will be stored in register 10. Okay, everybody clear? Clear?
Yes.
Okay, so what happens? Okay, what register that we want to investigate if we run this instruction? What register we want to investigate? Tell me quick.
Register 8, register 10.
Register 10, right? Register 10. Okay, what about register 8 and 9? Is it the value, the content inside those register, is it changed or remain unchanged?
Remain unchanged.
Remain unchanged because we didn't perform any changes inside it. We just add content of register 8 plus with the content of register 9 and the result stored in register 10. Okay, so let's investigate register 10. Mana tadi? Okay, register 10. Okay, currently the value of register 10 is what class? Tell me.
0.
0. What happens if you run this instruction? What is the content of register 10?
The
5.
content of register 10 is 5.
Is 5. Nama?
Item.
What is my Aida? Very good Aida. Okay, the rest agree. 10 ke 17? Ada tak yang jawab rasa jawapan dia 17? 17. Any of you answer 17? Anybody think the answer is 17? Is it 17? Or is it 5? Class, do you think 5 or 17 the answer? 5. Okay, so let's perform the single step. Okay, now we perform single step. Now you can see the results for register 10 is 5. Okay, everybody clear? Everybody clear?
Yeah.
Okay, so that's indicate the end of our lab today lah. Okay, so we can take a rest lah. Okay, until then if I have anything to ask you for submission, I will inform you later. Okay, with that, almost the end of our lab session lah. Okay, anybody have any question before we end our session? Any question? No question, class? No question, class? Everybody clear?
Yeah.
Okay, okay. So I hope you have benefited for the lab session. Okay, if no more question, you can take a rest afterward. Okay, thanks for your time. Assalamualaikum. And good day.
Thank you, sir.
Thank you,
Thank
sir.
you, sir. Have a nice day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.